Good morning, everyone, and welcome to this event dedicated to space, organized in the context of the EIC Communities Project and the Future Tech Week in coordination with the European Innovation Council and with the Programme Manager, Stella Tkatchova. This event is recorded, so if you don't want to appear, please turn off your camera. Just a couple of words on the EIC Communities Project. It is an Horizon Europe project coordinated by APRE, that is the Italian Agency for the Promotion of European Research, together with four partners, ICOS from Italy, EURA from Portugal, and the European Business Innovation Network from Belgium. And the aim of the project is to work to support the EIC-funded projects to be valorized and to have opportunities to enlarge the network and shorten the time to go to close to the market. So several activities, mainly online, are organized to develop discussion around the relevant topics and to provide opportunities to matchmaking the projects with the relevant stakeholders. To do this, we have created 3 communities of practices, one dedicated to clean tech, one to health, and one to industry that includes also digital and space projects. We have also established a platform, a website mainly, that is called deepsync.eu, in which you can find the list of all the projects selected thanks to the collaboration with the program managers that are part of the communities of practices and the stakeholders too. I will give the reference of the DeepSync platform in the chat so you can visit by your own. And there you can find also the full program of the Future Tech Week with all the events organized by the program managers and the projects. So I leave now the floor to Stella Tkatchova, the program manager for the space portfolio, to introduce the today events. Thank you, Stella, for the cooperation together and to introduce our today speakers. Thank you very much.
Thank you, Stefania, very much for this invitation and for organizing everything and for your excellent support. So I would like to start with a short introduction of our space portfolio and who will be speaking today. I believe you see my screen. So today we will have presentations from, do you see it on full screen?
Yes, Stella, just put in presentation mode.
I did, but it seems to be a problem. I don't know why.
Okay, but we see everything anyway.
Good, good. So today we'll have from G-Orbit, Stefano Antonetti, from Audoria, Milen Bosio, and from LumiSpace, Hira Virdei, and from Perseus Space, Gonzalo Sanchez. So there will be a very short presentation on what's the role of the EIC, what are the challenges, the portfolio, and then I would like to see a short introduction of the companies. And we'll have, of course, a short discussion. But before we start with the introduction to the companies, I would just like to share with you a little bit of information or a sneak preview from our activities in the EIC space portfolio. So our role in the space industry is to fund game-changing innovation and high-risk ideas. We have a very diverse portfolio. And since 2023, we have had a very interesting topics. The last call, which we have had on space debris, is space debris sustainability resilience infrastructure about mitigation, remediation, and in-space recycling. And this year, we have an accelerator challenge for in-orbit satellite servicing and operation, in-space refueling, and also space-based resilience. So this is our EIC space portfolio. It's built on 3 pillars: space debris sustainability, enabling space technologies Earth observation. Now, today, I have invited the space debris sustainability pillar. They would tell a little bit about their innovations, about their ideas. There are a number of questions on which we will discuss linked to the emerging trends, the markets, the long-term vision which the companies have. So just a little bit of background. On the debris side, we definitely need green interoperable technologies, and there are more than 40,500 space debris objects greater than 10 centimeters, a lot of unexpected fragmentation events.
Stella?
So, yes?
Sorry to interrupt. You're still focusing on the first chart. I don't know if you move forward, but it's...
Yes, I'm changing. Strangely, I'm changing. I don't know why it's not working. Okay. So, do you see my screen now? Do you see it?
Yes, but still the first slide only.
Yes, the first
Stella.
slide. Maybe Stella, turn off your camera. Maybe
Is it okay now? Do you see the
background?
Yeah.
Yes, now it's moving. Yes, yes.
Okay, so I don't have to do it. I clearly have an issue with my. I haven't set it up correctly. Sorry.
Yeah, try to turn off your camera. Maybe it helps.
I don't know. Okay, then we have the space portfolio. So here are the three pillars, space debris sustainability. And actually, I have invited the companies from this pillar of space debris sustainability to talk about their projects, share the experience in emerging trends, markets, and provide long-term recommendations. This is what I was talking before about the space debris activities. Clearly, complex mission scenarios, increased costs of space operations, complex supply chain, increased technical operation and market risks. Now, something interesting which I would like to share with you is how the portfolio projects working together. So we just selected 7 projects from the space debris on the Pathfinder, but we already have a number of projects which work together. And as you can see, today we'll have a presentation from ETPAC, from D-Orbit, from Astrolift, of course, from LUMI, which is in category 1, and Audorio with the Cassiope project. So you see that quite synergies in the activities of the projects. This is a short result of our projects which were selected from Work Program 24. So we received very interesting proposals. It was extremely competitive. We received many on space debris mitigation so there was a very high number there. A lot on remediation, on various innovations and technologies, and very few on in-space recycling, but the ones we received were quite strong on laser cutting, welding tools for desampling spacecraft. So just some last observations. A very high presence of SMEs and startups, which show that there is a very strong interest in this market or this area. Submitted by my mono beneficiaries, very limited number of in-space recycling, but very strong interest in proposals on proposing technologies and methods and approaches for in-orbit satellite servicing and in-space assembly and manufacturing. And then just one last observation, lack of proposals on fragmentation models, which I found it very strange. A bit of a, let's say, concern from the space portfolio on the access to new markets and customers. Space missions expensive, capital intensive, but proactive portfolio quite beneficial. So thank you for now. I will stop sharing and I would start with first, maybe we can start with Stefano with a few words.
Yes, of course, Stella. Thank you very much. And thank you, everybody, for being here. Yeah, very few words. Like the Orbit is a company. We are about 500 people by now, and our since we were founded in 2011, our focus has been in the broader topic of space logistics, of which, of course, space debris mitigation and remediation is one of the, well, probably the main topic, because after all, even on Earth, managing waste is basically a logistic problem. Since then, we've been specialized in the space transportation missions and business. So far, we have launched 17 space transportation missions, and now we are moving fast into space debris remediation, and both with the support of many institutional programs, including Astrolift from the EIC, including RISE from the European Space Agency, including the national IUS program from the Italian Space Agency. We are basically leveraging on those programs to develop commercial capabilities of being able to tackle this market, because we are very much market focused, and it's very important to identify, according to us, a market on which those technologies can bring a benefit for the customer, and of course revenues for us in order to grow the company and being able to sustain our employees. In particular, on our program with the EIC, which is called Astrolift, we are looking into robotics. Robotics is one of the most important technology to perform this kind of activity, such as space debris remediation. And so we never dealt with robotics before, so we are understanding through this program how to integrate robotics in our existing and future spacecraft, studying the dynamics, studying all the features that would allow our spacecraft to be more efficient and robotics ready, and therefore better suitable for any activity related to space debris mitigation in orbit servicing. I'll pass the ball back to Stella.
Thank you very much, Stefano, for the on-time and excellent presentation. So then I would like to invite Milen, from Audoria.
Yes, so good morning to all of you. You hear me? Yes, okay, great. So Aldoria is a French company focusing on space surveillance. So we are deploying an optical ground station all over the world to do space surveillance, and of course debris is part of it. So we have two different I would say axis. The debris is one of it, and the second one is focusing on space assets and how to secure and to protect what's going on in space. So we have developed and patented a multi-telescope observation system, which is a 4-telescope synchronized to do screening and to screen all the objects and debris in LEO orbit. And we have also a single telescope observation system, mainly to do tracking in geostationary orbit. We have today 3 station MTOS and 3 station STOS all over the world, and capable to cover, I would say, 95% of the geobelt and around 70 to 80 in the LEO. We've raised 10 million in Series A beginning of last year. We have today 55 employees, around 35 in Paris, 10 to 12 in Toulouse, and we have also an offices in Austin in the US. And we are so basically 3 different axes. One is the system. The second one is the surveillance. So basically to save data to institution, military, customer, and commercial one. And the third one is delivering services, so collision avoidance, threat detection, maneuver recommendation. So these are the 3 different axes we are covering within Aldoria.
Thank you so much, Milen. Very much appreciated. So then we continue with Hira from Lumi for laser debris identification.
Excellent. Yes, thank you, Stella. So at Lumi, we are a British company. We are developing a network of ground-based lasers to detect and track debris, very much complementary to existing technologies like optical and radar. So our roadmap includes pre-preparing satellites for detectability, trackability, minimizing the impact on dark and quiet skies with retroreflectors. We have a whole bunch of flight heritage and some interesting constellation progress there. Deploying the network of laser ranging stations and eventually moving towards nudging and removal using ground-based lasers. So I'm sure we'll get into a lot of the details of the proliferation of space debris, of how we clean up the environment, but really to focus on that ground-based technology, which as part of the EIC portfolio, we're going from existing laser ranging stations that are large, expensive, take a long time to deploy and to get the right approvals, to a commercial model where we provide somewhere between 100 and 1,000 times more accuracy than typical radar data to commercial operators, with some applications in common with other space surveillance companies. Yeah, I guess I'll leave it at that for now, but keen to get into things.
Thank you very much here. So, and now Gonzalo from the Persei Space. It's a project which started as an idea from the Pathfinder, from the FET program, and now it's in our transition. And so, Gonzalo, please go ahead.
Thank you, Stella. Thank you for this invitation. Shall I share my screen and prepare a couple of slides, or do you want me to do it? Okay, I will then share it.
It is your own choice. If you want, you explain it. If you want, you share the video so people can
I think the audience will understand better what we do with the video. Okay, so we'll put this here. Okay, so we, as you said, Stella, we are an initiative that we started in 2019 in the framework of a Pathfinder project. And our vision, the vision of Persei Space, that is the company we founded as part of the work of this project, is to use natural resources of the space environment to lower the cost and operate in a sustainable manner. And for this, we want to use a technology that is called electrodynamic tethers, that are long conductors in orbit. And this technology has three important characteristics. The first one is it is a propellant-less propulsion system. The second one, it is energy reversible. They can convert orbital energy into electrical energy and vice versa. And in third place, it is a scalable technology. So the value proposition of the company is to offer a propellant-less propulsion system for deorbiting, reboost, station keeping, and power generation. So here you can see how the technology works. So this is our deorbit device on board a satellite. So when the mission has finished, our deorbit device takes care of the detumbling and to deploy a tape of aluminum, that is the electrodynamic tether, that collects electrons from the ambient plasma and generate a current that interacts with the ambient magnetic field to produce the Lorentz force that decreases the altitude of the orbit until the satellite is eliminated during the re-entry. We had a Pathfinder project called ETPAC that ran from 2019 up to 2022. And the goal was to develop a deorbit device based on EDTs, on electrodynamic tethers. It has a mass of 20 kilo and a volume of 12 U, and it is fully autonomous. Here in this picture, you can see the prototype with it in ETPAC. And then we, as you explained, Stella, we are now implementing an EIC transition project. It's called ETPAC-F. The F comes from flight, because the goal is to prepare a flight-ready deorbit device. We have recently finished the preparation of the engineering qualification model. That is the one you can see here in this picture. And also, in the framework of this project, we create a Persei Space. That is the company that will mature and will commercialize electrodynamic tether products based on the results of the ETPAC and ETPAC-F project. We have done the testing campaign of the EQM. You can see here all the tests that we have performed: vibration test, pressure test, leak test, electromagnetic compatibility, deployment test, thermal vacuum, etc. And we are very, very excited because we have an IOD scheduled in 2026. We are now preparing the flight model, and we're going to fly our system thanks to an EC-funded flight launch opportunity in the framework of the flight ticket initiative. So the flight will be in Q2 2026. And we were also very lucky because we were selected for another Pathfinder project that is called ET Compact. And the goal of ET Compact is to prepare a miniaturized device with capability for propellant-less propulsion and power generation based on bare photovoltaic tether technology. That is a new type of, an innovative type of tether that is able to harvest power and to provide propellant-less propulsion. So the goal of ET Compact is to explore the miniaturization limits of tether technology while contributing to the development of perovskite fixed thin field solar cells for space applications. And well, the company has now 3 employees, and we have applied to several grants that we are now under review, and we also submit an EIC accelerator proposal recently. And I give to you the floor, Stella.
Thank you very much, Gonzalo. So let's start with our discussion. Maybe directly, I would just share again the screen with the first slide. Or maybe Stefania can share the slide which we have from the, let's say, from the discussion. My first question to you is the following. So let's start with the questions linked to emerging trends. And again, I would start in the same order with Stefano, and then following up with Milan here and Gonzalo. So in your opinion, what are the major gaps, issues for developing green, interoperable and affordable space debris remediation technologies? Stefano.
Yes, thanks for this question. Let me try to be give an alternative answer here, because I could make a long list of technologies, but then I'd say, to me, the major gap is market. When you have, history proves that when you have a clear market, technology can go very, very fast. And it doesn't matter what the technology is. And sometimes we also have the pretension in space to say that, everything in terms of technology is very difficult, which is true. Space is very hard. Although, on Earth, we had overcome huge challenges huge challenges, and we'll still be able to tackle very incredible products. So yes, I would say definitely market. We need more traction. We need, especially for space debris. It's not clear who's going to pay for that kind of a service, and regulations plays a key role on that. As you know, many countries that are issuing their own regulation, but we still need an harmonization at the country level and global level. That doesn't look like now to be around the corner. So I'm not saying that market is more important than technology, but definitely if no market, we can develop even the best technology on Earth and nobody will buy it.
Thank you. Thank you very much. So then maybe Milan, sorry, here the image is not you, it's Christine.
No, that's fine.
But that's fine, I think. So, so yes, Milan, please, what are your, so from what I take from the orbit, it's really the gap is the market. And then for you, Doria, Milan.
I fully concur with what Stefano has shared. Maybe there are 3 different axes. The first one is markets, because if there is no market, it will be very challenging for company to really focus on this aspect, because all in all, we want to be successful and to do business on it. So if there is no market, there is no goal to have a company. The second one maybe is technological limitation for the time being in terms of capture systems. Maybe we are still in very early stage of development, and it's still really high cost in terms of developing such technology. And maybe the third one, and it has been a bit shared by Stefano already, maybe one of the main challenges is institutional in terms of lack of coordinated political will to impose standards and shape a viable market, because space is a global common with no really shared governance. And if there is no action around that, I guess there will not be any sustainable way to take care of it.
Thank you, Milan. And Hira.
Yeah, so I mean, I've been around the space debris community for some 15 years, and I think there's been a lot of discussion on things like regulation, on you know, the good practice in common grounds. Realistically, people have been talking about things like regulation for a very long time. The problem is very well characterized, very well known. I think this requires a very different look at commercial viability of once you turn things into a financial need that improves the bottom line of a customer, that's the way to drive these technologies. And that requires innovation in things like business models, pricing. To Stefano's point, technology is necessary. But all of this comes down to the bottom line of space being a means to achieve business goals. If we're looking at this in a kind of true commercial sense, and I think in many ways that's the only way to drive action. Because space is a global commons, anyone that tries to regulate or to increase the barrier to entry, increase the kind of underlying, it sets an uneven global playing field. And we do see, especially with recent constellation filings coming from interesting and wonderful countries that are not typical space players, that the largest companies with pure commercial interest will simply step around whatever regulation that those of us who are maybe more conscientious would like. So I think at the end of the day, it all drives down to technology driving commercial value for a set of stakeholders.
Thank you, Hira. Well, that will be a bit later. We'll discuss exactly the market incentives and the economic one a bit later. So, Gonzalo, what about you? What are the major issues which you...
Yes, there are certainly issues and gaps that need to be filled. But maybe before speaking about this, we need to see the bottle, that there is already some water in the bottle, because a lot have been done. And actually, last week in the European Conference on Space Debris, we can see that, for instance, the community grew a lot. So there are now more companies and more people thinking about the space debris problem. I think this is very important because at the end, all this activity, they have generated technologies. They are increasing the TRL of key technology for capture, for rendezvous, for proximity operations, for deorbiting. The catalog has been improved. So I think it's important to put in value what it has been done in the last years. But as you said, there are also gaps. And in terms of gaps, I highlight the one mentioned by the speaker before. The market is not clear. I mean, everybody knows the market will be there, but the rules of the market and the size of the market and who is going to pay, these details, they are still under development, let's say. And when we speak with investors, they would like to have more clear information, more quantitative information about this, and identify this as a gap.
It is a very, very tricky question, a long-term question, which is like a cloud over the SSA community, the space debris community, because it is, everyone realizes there is an issue, but no one wants to pay for it. So very few. So it's a very big issue and limitation. So I would like to continue with the questions linked to, and again, I would start with Stefano. In your opinion, what are the type of emerging disruptive technologies in your domain for remediation, or, for example, in the long term for space recycling? as you know, we need to tackle also the space debris challenge, not only in LEO, but there is also issues with MEO. And particularly, I'm interested in your opinion for the small debris and the 1 centimeter and maybe the non-cooperative ones. So.
Yeah, thank you. First of all, well, this is well known, and since ages, I mean, we need to increase our capability of know what's up there. So space domain awareness, space situation awareness are key. We need to increase those capability. We need to introduce concept of space traffic management, because that's definitely the first and necessary step to mitigate the debris. So like, in order to solve your problem, you need to know your problem. And after you know your problem, you need to stop causing it. So definitely space debris remediation and all the techniques are super important. So, I mean, there are many ways. It's in tether, the orbiting motors, solar sails. There are many ways. It's not a perfect way for all the applications, but definitely, you know, like increasing the technology level of all those systems that can deorbit satellites in a safe way, definitely it's priority number 2 after SSA. Regarding orbit servicing per se, so space debris remediation, I think it's very important. I mean, technology is more or less there. I mean, we already have done docking, even on cooperative docking. The technology is more or less there. What we need is more cooperation between the key stakeholder and the technology developers. So therefore, like actually the clients, the customer that actually are going to need to be removed. So we need to talk to those people to understand what are the interfaces of their satellites, in case the satellite is cooperative, to understand how not to disrupt the operation. In case the satellite is not cooperative, we need to understand the design, how it's done, really, in like the drawing, basically, to understand where we can catch it, how we can handle it. I think this is, it looks trivial, but it's super important. To achieve those data, it's super difficult. About recycling, okay, that's a completely different story. Recycling, in my opinion, we don't have the technology now, and we don't have the use cases neither. Recycling may mean a lot of things. I think the first step towards recycling will be orbital assembly modularity. So we'll be reusing some parts of some satellites for other things in a modular way. For proper recycling, we need to develop a lot of technology, from 3D printing, from melting, from even design satellites in a different way, which is a completely different story. And we need to do a lot of work on that.
I do agree with you, because actually now with the last call which we had, that's what I observed also. There was very few proposals on in-space recycling, very, very few. And it's a very early stage area. I think talking about in-space recycling, it's probably like TRL1 or TRL2. It's very low TRL and very little interest, because I think it's a very long term, maybe in 20, 25 years, we might see it realized. So, but thank you, Stefano. Now, as you were talking about space situational domain, SDN, SSA, I turn again to Aldoria and Milan, because I guess they will have some, maybe they will be talking about different types of sensors or new technologies for mitigation and how to actually tackle the space debris challenge, particularly identifying 1 centimeter debris, really small debris. Milan.
Thank you, Stella. Yes, I mean, within Aldoria, we have, as I said at the beginning, patented a technology which is capable to see objects between, I would say, 7 to 10 centimeters in LEO orbits. And we have installed our first one with a larger camera in the Canary actually now, which will be capable to detect lower size of objects, so in the range of 5 to 7 centimeters. So more the size of the telescope is large, better we can see a smaller object. And in the plan, we have also a 1 meter telescope to detect between maybe 2 to 4 centimeters debris. So this is in the roadmap to be able to detect very small objects. Now, I think the technology is necessary, but I would say not sufficient. What we need, we believe, is a new orbital architecture, which will combine AI, robotic arms, ground-based optical plus radar for space surveillance with a modular tugs. We believe these are the critical components. And I think this integration into a more dynamic, responsive system that will really matter. And really, the real shift is from reactive fixes to systems traffic management. So we have technologies that are capable to detect small objects, and we will have to detect smaller objects in the future. But we really believe in a global architectures, orbital architectures landscape.
Thank you so much, Milan. So, Hira, your turn.
Yeah, I think there are some novel technologies and use cases that certainly we're looking to deploy alongside others as we see necessary, because I think this is very much a collaborative industry. As Marlene said, I think there is the need for optical tracking, the kind of large telescopes as they're deploying. There's a need for radar, and there are a couple of companies that we're collaborating with. And then there's a need for other novel forms of data, some laser ranging, some space-based. So we have a European governmental stakeholder with whom we are deploying a space debris laser ranging station with a view to minimizing the size of observable debris. We think sub 5 centimeter is rangeable. So we need to work with collaborators to get the a priori information so we know where to point our lasers to then be able to improve the information. So it's very much a collaborative ecosystem approach rather than that there's any one company that's going to solve all of this.
Thank you. So I hear the same message already from all of you, and I guess, well, I'll let also Gonzalo express here, but it's about the customer, the client's customer requirements, and to see how the customer needs will be the one driving the market-driven technologies, basically. That's what I understand pretty much. Mm-hmm. So, Gonzalo, and then there will be some questions, I think. Gonzalo, please go ahead.
Yeah, in my case, I can speak about the orbiting technologies. That is the one that belongs to my field of expertise. In that case, we have two families of technologies, active and passive. Active includes chemical propulsion and electrical thruster. Chemical, we know we can deorbit with chemical propulsion. They have a high TRL. The problem of the chemical thruster is the cost of the propellant, of launching the propellant. So the mass that it will represent for being clean. Let's say if you want to deorbit something and you need to dedicate 10% of the mass just as mass of propellant is too much. Also, it's difficult to prepare autonomous deorbit devices based on chemical thruster because the thrust need to be given in the right direction during a short time. So this poses a tough requirement on the ADCS, especially when you are attached to an object that does not collaborate with you. The second type of active technologies is electrical thruster. They can reduce dramatically the mass of propellant, but they need power. So for sure, if there is a chemical thruster on board, this can be a solution for deorbiting. You just save propellant and use it for deorbiting. But what's happened with the satellite that failed? What's happened with this? And also, we are not aware of any autonomous deorbit device based on electrical thruster. And now if we move to passive technologies, we find sails, so drag augmentation devices. They do not decrease the area time product. So this is a problem they have and at the end, the collision risk is proportional to this product. And also the performance of the sail decreases dramatically with the altitude because of the lack of air. And also says they have to face the challenge of scalability. And the second passive technology is tethers, electrodynamic tethers. That is the one we're working on. They can offer good performance and they can be used to prepare autonomous deorbit devices. But we need to increase the TRL and we need to demonstrate them in orbit. So we still have a path to complete. Tethers, maybe they have an advantage that is linked with something that was mentioned before, that is who is going to pay. A strong point of tether is that meanwhile they are deorbiting, probably they can add value to this maneuver because they can collect scientific data because they interact with the ambient plasma, they excite waves. So I see there are some synergies that maybe can be used to find other actors that could pay for this deorbiting in case we will use tethers. But there is not a magic technology that could be used in all the scenarios with a low cost. That we are sure about this.
Thank you, Gonzalo. Now, before we dive deep into the market questions, there is a question from the audience. Manuel.
Hi, hello, everybody. I just wanted to make the question when we were talking about recycling, Stella, but one of the key points, we were evaluating that scenario on the preparation of a consortium last year for the call that was supposed to take place in October. And one of the things that we found was that the power for recycling operations of any method that is needed is very high. So those capabilities for power supply, maybe you can provide a short update. Is where are we standing in terms of solar power, photovoltaic cells, and what's the maximum power that we commercially can achieve here in Europe from the market? We know that we can get 40, 20 kilowatts power PVs in the United States. We know that this is commercially available, but how is Europe doing?
We are not hearing you, Manuel.
You are not hearing me?
Yes. How is Europe performing, basically, you're asking?
Yeah, where are we standing on solar photovoltaic power technologies for
this is a good question, but at the moment we are not. This is a very good question, Manuel, but at the moment we are discussing space debris sustainability. You're right on the capability for power supply for in-space recycling and in-space assembly and manufacturing. However, we have selected 9 projects from the call from 2023. We have a special working group on solar cells. We have one on wireless power transmission and one on in-space green propulsion. And actually, every working group is working on preparing a white paper or an article, but they will be also presenting their results during the portfolio meeting on the 3rd of July. So pretty much, I mean, I think this is a topic we should discuss out of this area because we have quite a few other questions. So if you don't mind, Manuel,
no problem. No, absolutely not. I just wanted to know the state of the art because recycling without those powers, 20, 40 kilowatts at least is going to be what is going to be.
I agree with you. So please, let's dive. I would like again to turn to Stefano, which the question is, I mean, we did talk about the gaps, the issues, the opportunities, but I would like to ask a question which is more of a market question related. What should be the economic or market incentives for encouraging developing disruptive technologies and services for space debris mitigation, removal, or in space recycling? Stefano.
Thanks for the question. I mean, like long time ago, a couple of years ago, I made a proposal because like on Earth, how do we tackle the environmental problems sometimes with incentives? For instance, if you want to buy your electric car, usually, like in most European countries, you got incentives by the government because it's not convenient, right? If you just want to decide whether to buy a normal chemical car or electric car, if you just base on economic value, you just buy a normal chemical car. And the incentives by the government makes you willing actually to buy an electric car. I think we should do the same in space. I don't want government to pay me as a technology service developer. I want the government to pay my customer. So it would be interesting to explore a scheme where there are incentives by the government to satellite operators, so to final customer, to buy devices to be, like compliant with space debris remediation and mitigation rules. So, for instance, if you buy a tether system from Gonzalo, you get, I don't know, like 60% of the price paid by the government because you are making actually your spacecraft greener. So, very similar scheme what we do on Earth. I think that could be a good stimulus for the space debris mitigation remediation market for operators like us. It will really foster competitiveness because it doesn't sustain technology, but sustain customers, and therefore generally a more competitive solution.
Thank you very much. Very concrete example, very good example. Thank you. So, Milan, your recommendation.
So, I mean, because I guess you move forward I mean, you are talking about recommendation in terms of all the different area.
So my so basically we skipped the technical questions as I see the interest is much more on the market than on the commercial side. And the question is, what should be the economic and market incentives for encouraging developing disruptive technologies for space debris mitigation?
I mean, it's I think we are turning around more or less the same challenges, I would say, in terms of market and who is paying for it. Because in terms of technology, I don't remember exactly if it's Stefano or Gonzalo who mentioned that, but I think we will find the right technology if we know who will pay for it in terms of development. And if there is a market for it at the end, meaning that the company would be successful by providing this technology to the market. So my recommendation would be more on the institution and funding area, and also in terms of legal recommendation. We need to get a more collaborative, or at least one single voice for this type of challenges, and the technology will follow. So my recommendation is really to focus on the institution recommendation and lobbying on that, because it's very important, and there is no regulation on space. So I think this would be my main recommendation. To
Thank you, Milan.
On the regulation. Yeah.
Thank you. And I would, Hira, do you have anything to add, or are you fully in line?
I would challenge that a little, maybe. That I think, we've seen for a long time that regulators, agencies have key interests here and have been talking about, I remember maybe it was 2013, one of the previous ESA space debris conferences, right? And I think the conversation, I think we've taken some major steps in the last 2 to 3 years, both within Europe and globally. in identifying and setting out some best practices. But if you look at the ESA Zero Debris Technical Booklet and the guidelines, right, that is a non-binding, it's very much optional. So I think to actually have impact, what we need is something that's commercially viable, something that's interesting, something that's low cost. Get something out there, because something being done today is better than people thinking and talking in the same way that they were in 2013 as they were in 2025.
Thank you, Hira. Very good recommendation. And Gonzalo?
Yes, I would like to ask something. I think there are two ways. The first one is the one mentioned by Stefano. I fully agree with him that having support from public bodies is crucial, especially in this early stage. So if government can create some incentive for opening this market and vigorize the market, this is essential. This is one leg, I would say. But I think there is another one, or we should create another one, that is, okay, there are companies now, and they are launching many satellites. So they are populating the space with debris, and they're making money. I think we can also add something to them, to the private sector, not only to the public body, but also to the private sector. So maybe it's time to create a tax for the satellites that are launched, and this tax is dedicated to promote the economy of space debris. So this tax can be used to pay for the orbiting devices. This tax can be used to pay active debris removal missions. This tax can be used to improve our telescopes to monitor the space debris. I don't know. There are so many things to do, but I will put the focus not only on the public bodies, but also in the private sector, because space is a business. So they should also be responsible for it.
Gonzalo, I like your idea for the tax. Actually, I remember Wubbo Ockels, the first Dutch astronaut. He was part of my PhD committee, and he was talking already 16, 17 years ago, exactly having a launch tax in the long-term future as a way for environmental protection. So I think the idea has been, it's a very good idea.
Actually, it's not my idea. I mean, this idea, as you said, it has been in the public debate for a long time, as you said. We can also think about trying to find other friends for space debris. So, as I mentioned before, if we're able to add value while being clean, this will also help to vigorize the market. We need to think what are the people or what are the actors that could benefit indirectly by cleaning the space. Maybe geophysicists, scientists, I don't know, other companies. We may also think about not only the space sector, not only about ourselves, but also about other people that could also benefit and could also pay and could also contribute.
Thank you, Gonzalo. So let's go with the next question. So
we have a question here.
Stella, yes, there is a question in the chat, and also
Stella,
a hand raised from Celeste Pereira.
Yeah, please go ahead, Celeste. Sorry, I didn't see that you had your hand up. Looking forward to your question, Celeste.
Good morning, Stella. Thank you for organizing this event. For me, it's very helpful. It's nice to have here to meet other people that is also dealing or interested in the field. So it's an opportunity when we don't have the opportunity, for example, to travel, to go to the all around events that are being organized on this field. So concerning your question and the incentives, I see that there is a market because there is a problem. There is the debris that are problems. So there is a real need to find solutions. So this market exists, is not yet fully, of course, developed and I will say organized as other markets are in herd, but the market exists. The problem, in my opinion, is we are forgetting the aspect of environmental sustainability. also not only the economic sustainability, but also the environmental sustainability. And this environmental sustainability is also linked to the debris that affects the launch of new satellites or creates problems. So the market exists, there is a problem, it should be really quantified, it should be, I will say, more developed this aspect. And of course, if it is known by everybody, also the ones that launch new satellites, it's like on Earth, we don't want to have the waste in our streets, so we pay for the removal of this waste. The same is, for me, natural in space. It will come by that reason. There is a problem.
Thank you very much, Celeste. And actually, that is an aspect which the European Commission has been investigating, and also colleagues from ESA, to design spacecraft not to create additional space debris. And I would say, I believe my colleagues also from ESA, they're also working on zero debris book and requirements. Maybe if they want, they can actually also connect and talk a little bit about it, because it's very, very important to really not to create additional debris and not to pollute Earth's atmosphere also, because with the burning spacecraft, there might be an increased pollution. So environmental sustainability was something which we were looking at very much also when we were selecting the proposals, thinking about how not to create additional pollution. So that was one of the main areas when the experts were selecting the proposals. Okay. Thank you,
Stella. If you don't mind, I would like also to add another aspect, that is the resources. So end-of-life satellites or the debris that are already in space are resources. The same is being developed in Earth. Waste be transformed in useful resources, chemicals and other things. So really, there is a market there.
But I agree with you, Celeste. That's why we had in-space recycling. But as observed, there were very few proposals. If we can treat space debris as a potential resource and treat it and be able to recycle it, I think it will be really great. But it
will be perfect. Yes.
Thank you, Celeste. Okay. I see Sasha.
Thank you.
He's actually, maybe Sasha, can you connect? Sasha is a colleague from ESA. Can you just say a few words about the Space Debris Charter and technical booklet?
Can you hear me?
Yes, we hear you very well.
Okay. So just quickly, in terms of the Zero Debris Charter and the Zero Debris Technical Booklet are indeed non-binding. That's what I wrote in the chat, but they are not meant to be binding. It's more to build a unified voice from the whole space sector. For the charter, it's more about raising awareness and trying to push for criteria, parameters, some targets that everyone would agree on, and that afterwards people in charge of making policies could use. And for the technical booklet, it's more to like a technical roadmap. It's to see, okay, what are the needs, what are the solutions we have, what we still need to develop, and potentially the key enablers. So Sam, it's more to provide technical aspect to it. And so this is what the Zero Debris Initiative is about. But apart from this, in terms of regulation, so we have the American FCC, which is I'm not an expert in terms of I have a like engineering background, so from I would prefer someone with a legal background to talk about this. But from what I understood, we have this American FCC that is imposing like requirements in terms of debris mitigation and remediation, in terms of how long after the end of mission a satellite or a constellation can stay in space. So it is applicable to every launches in the US, and we have a bit the equivalent with the French laws, space law. And identically, ESA has its own zero-debris approach, which is also applicable to all of its suppliers. And so this is indeed a binding framework for all of ESA contracts and program. So I'm not sure I have answered to any question or anything.
Clear,
but just to
Sasha.
this comment, there is no regulation in space.
It's complementary.
Yeah. It's coming. Maybe it's not comprehensive. Maybe there are, of course, many gaps, but we are working on it.
Thank you so much, Sasha, for your for jumping in. Appreciate it, and I do believe that the Zero Debris Charter is very good, and also the Zero Debris Technical Booklet is a very good guidance. Also, Europe, my colleagues from DG DEFIS, they're working on a space law and regulation, but I don't want to comment on that because that's their domain, and I do not comment on areas which are much more linked to regulation aspects. I prefer to talk about the technology innovations and the market. So let's go back to the markets. My question is on the to Stefano. What are the long-term emerging markets you foresee for in space remediation or mitigation or in space recycling for the next 5 to 10 years? And how do you think investors will perceive them, in your opinion? It's a very political, well, not political, very strategic question.
We're not talking about geographical market, right?
No, not about geographical market, not at all, not at all.
Okay, so my personal opinion that, I mean, of course, the large constellations that are going to emerge in the next few years, that will be a big market. In Europe, we have even several institutional constellations such as IRIS², or we've got Copernicus. So we've got many missions that will need to be removed possibly at the end of life. That's definitely a market, but it's not big enough, in my opinion. And also because that's a huge need also to contain, to reduce the cost of those constellations. So if you add on top a space debris mitigation service, that could be much more expensive overall, unless you include already in the design of those constellations some measures that makes the constellation itself cheaper. So what I mean is, like, if a constellation costs 100, right, and in order to remove it, you have to pay another 100 to do debris removal, then you got 200 cost of the full constellation, and that would be too much. But if the presence of debris removal service will allow those satellites, for instance, to have no redundancy, or to have like commercial components, so instead of costing 100, cost 20, at that point probably adding on top active debris removal services would be viable. So I'm not saying I'm pessimistic about the market, but definitely I don't think it's going to explode. It's going to be ramp up that quickly on the short terms. And so we need to, from our perspective, from industry perspective, we need to discuss with that relevant stakeholder, commercial and institutional, in order to understand what would be the best strategy to have a sustainable business out of it. Otherwise, it would be a huge amount of imagine institutional money floating in this topic. I don't think it's that this is the objective of everyone.
Thank you, Stefano. Milan, I'm going to you.
Yeah, I think I will. I have nothing maybe to add to what Stefano mentioned. So
he summarized the question, the answer of everyone pretty much. Hira.
Yeah, I think the challenge from an investor's perspective, especially when we look at something like space surveillance, is that you have a limited customer pool, some of whom are looking to share data with each other. If you look at the mitigation side, we have government-funded missions to demonstrate. I don't know how far we are from a mission to commercially remove, right? Because what's the incentive? If someone is going to launch a satellite and expect a bill of, let's say, based on current missions, 40 to 100 million euros for the end-of-life removal, why would they go about that? That's a decent chunk of another block of their constellation. So I think there are major commercial challenges, and I think that's one of the reasons that private investors are quite afraid of this area, because the commercials are not very well demonstrated. And even if you see, taking Astroscale as an example, a listed company where in Japan, actually at Spacetide last year, Nobu was on stage kind of saying that we're interested in and closing towards a business case that works. And we're still at that stage of talking about the business model, and that really scares investors off. So investors are happy in some ways to come into space. That's already quite risky because it involves hardware, it involves long lead times. But when we look at sustainability and mitigation and remediation and tracking, there are more questions than there are answers at the moment. So, I mean, going back to the previous answer, I think it's about what commercial services can stand up purely commercially, rather than necessarily just being stood up by kind of governmental programs, by grants, etc. I think it needs to be a combination of the two, where you've got clear commercial demonstration and then kind of boosted through TRLs by these types of programs.
Hira, will you now, just to complement, in your opinion, do you think the Japanese model, which they have, the program which they have with RDAS-G, is a good model, let's say, because the Japanese agency has this kind of a commercial agreement, and it could be, could it be an interesting model?
I think it's interesting for different reasons than one would expect. That it doesn't necessarily, it stands up a capability rather than standing up a service. Okay. So the result of the RDAS-J kind of rendezvous and imaging, the result of even a kind of ADR mission for an upper stage, is not saying that someone will utilize that service. It's saying we've built a capability that can do some interesting things. Right? I think you have to look at, especially in this geopolitical environment, the nationalism, the desire to stand up unique services that are critically required globally. In some ways, it's better to look at Astroscale as Japan's answer to SpaceX as a national security play for space than it is as a space sustainability play. So there are some interesting things there that don't necessarily go to the core of sustainability.
Thank you, Hira. Thank you. So going back to Gonzalo, I would just go back to the question, what are the long-term emerging markets you foresee for the next 5 and 10 years? And what are the main, how do you think investors perceive the space debris market and startups? Gonzalo.
Yeah, in terms of market, the ones that are, again, closer to per se, we identify 2 of them. The first one is the deorbiting of satellite and the micro launcher, because every micro launcher, there are micro launchers that leave several pieces per launch, and some of these pieces, they don't have a propulsion system for deorbiting, so we think that there a market can be open. The other one is the obvious one, to incorporate in satellite deorbit technologies, so they can be used at the end of life. So this is one branch. The other one is in-orbit servicing. And there we see 2 possibilities. One is the preparation of autonomous deorbit devices that could be on board in-orbit servicing vehicles. And this in-orbit servicing vehicle can install these autonomous deorbit devices in different customers. Because I think we have to move from an approach that is one up, several down. No, it cannot be that we launch one mission to deorbit only one piece of space debris. We need to change the model. We need to send one iOS vehicle, and with this, we should be able to deorbit several. So this idea of using several autonomous deorbit devices on board the in-orbit servicing vehicle can help. And also we can think about changing the propulsion system of in-orbit servicing vehicle from a propellant-based technology to a propellant-less technology. Because if we equip in-orbit servicing vehicles with propellant-less propulsion technology, for instance, with a tether, it means that the same vehicle can go up and down many times. So again, we are moving to an approach with one up, several down scheme. So this can increase dramatically the revenues of in-orbit servicing companies like the Orbit, Astroscale, etc. And also, something that we should not forget is that probably while developing this technology for space debris and opening this market, we can also use this technology for other applications. For instance, for last mile delivery, that is another in-orbit servicing market. For the compensation of the drag of space stations. As you know, there are now many initiatives to construct a space station. So if we want to compensate the aerodynamic drag by using propellant-based propulsion system, this is going to penalize the performance, let's say, of this space station. So I think we should look into the market of space debris, but also to identify what are the other markets where the same technology can also be applied for.
Thank you very much, Gonzalo, for your clear recommendations. And I see a question from Trunau Patio. Trunau, shoot.
Yeah. Thank you, Stella, for organizing these very interesting discussions. My question is very specific about space recycling. So with rising orbital these congestions, like expansion of like satellite mega constellations, how critical it is to prioritize investment, like prioritize to focus on space recycling now rather than focusing in decade later, because specifically since these space debris are like provide very key resources for the sustainable in-space manufacturing. So shouldn't we focus on recycling infrastructure as seen as like core driver as a future space economy rather than just extension of the debris removal? Because so long story short, is there any active project going on space recycling in the EIC? I just wanted to know that.
So Trunau, there is no project on in-space recycling at the moment. We just closed the selection of proposals from the call, which was the call was now on, we closed the evaluations in February. We have selected one or two projects for in-space recycling and reuse of orbital assets. One is looking at laser cutting and welding tools for disassembling spacecraft and developing refuelable electric propulsion technologies, and the other one is developing a capture kit. So actually, these projects were selected, but they haven't started yet because there is like the initial phase of they just got the letters like 2 weeks ago, and now they're in pre-grant preparation, which means that now there is all the technical checks of all the partners, consortiums, and so on, and that takes many, many months. So most probably the selected projects for in-space recycling will start probably in September or October. That is on our side. I do not know whether there aren't any in-space recycling projects with other colleagues. I have no idea whether ESA has some. I know they've done some feasibility studies, but I'm not aware. Or my colleagues from DigiDev. So it's a very low TRL innovations. Okay.
Thank you, Stella, for this interesting answer. And I'm really happy that there is something happening in the EIC. Partner call. Yeah, I'm also particularly focusing on mechanical space recycling in the European Space Resource Innovation Center. So basically, instead of focusing on the chemical recycling methods or like biometallurgy, we are focusing on these mechanical physical recycling methods, starting from the size reduction process and using different separation process, which is also environmental free and also independent from the earth resources. Yeah, but I think I'm also like happy to know like there's something happening on space recycling. Thank you for your
Thank
answer.
you, Trunau. So, Giro, because we have just 12 minutes left, or even 11 minutes for the end of our webinar, I had 5 or 6 more questions, but we will not be able to cover them. I would like to first thank you all for your contribution. I have one last question, and also to the audience participating and listening. So let's start with Stephanie. What are your final recommendations on how the EIC can further support space debris sustainability and how to support emerging disruptive technologies in this area?
That's a very difficult question. Basically, asking me to.
Okay, if you
Suggest
think
maybe
it's
how to do your
difficult, I'm
job.
fine. Just last words would be more than
No,
enough.
I'm kidding. I'm kidding. Okay, honestly speaking, you guys are already doing a lot by supporting all those technologies and companies and startup. I don't think really. I mean, my suggestion as a very practical space engineer that has like born with the lesson of the moon race in the 60s and 70s, that we should really focus more on trial and error. We should really try more. I think one of the problems in space in general is that a project, when it starts to when it goes to demonstration, it takes 5, 6, 7 years. That's not acceptable. If you want to tackle, I mean, as was said, I remember somebody in the audience was saying before, like, why should we focus on recycling now? Because if we wait for recycling to be mature, we will already have 100,000 satellites in space. That will be too late. He's absolutely right. We need to do trial and error. We need to accept failure. We need to accept mistakes by the industry, and we need to try fast. Really, it's not really just a startup motto. Try fast, fail fast. But I think we should, really go in that direction. And I think that would be my recommendation from you guys.
Thank you very much, Stefano. Thank you. I took a note. Try fast, fail fast, succeed fast, pretty much. Thank you. Next, Milan.
Yes, thank you, Stella. I think maybe supporting cross-sectoral projects with linking more the industry, startups, and institutions together. Also, thinking about what we can call the European Orbital Responsibility label within the EU Space Act, fostering a strategic vision beyond national interest, but having European and global ones could be also one of the recommendations. Yeah, I think this is basically.
Thank you very much, Milan. Thank you, Hira.
I think very, very well summarized already by Stefano and Milan. I think the only thing to add is lobbying for stakeholders to allocate some funds towards those kind of projects, because of course moving fast and having cross-sectoral projects requires us to have more money to do that. But I guess for everyone here, including Stella, to lobby the stakeholders that we have to increase the budget so we can operate more quickly.
Or lobby for more customers, for more commercial customers, I would say. Before we get to the lobby for the funding, we need to show to the investors that we have a potential customers. So thank you very much here. Gonzalo, last words.
Thank you, Stella. I have an idea, but I don't know if it is a bit crazy. I
Go
have
ahead.
identified I have identified two challenges especially for Pathfinder project. The first one is that when they have when they want to create a company, no, they have some result, they think they are promising, they think they are a market, so they decide to create a company. But creating a company without resources is difficult, and very often in Pathfinder, the beneficiaries, they are universities, so the people that are working, they are like me, professor at university, so there is a gap. And also in the Pathfinder, the contact with investor is not, there is some contact, but of course it's not, the TRL is very low, so it's difficult to establish a contact with them. So I wonder if it would be possible to create a group of investors that could be some kind of a sponsor or something, I don't know how to call it, okay, but a group of investors. And each of these investors, they allocate or they contribute with an amount of money, I don't know, something. So we create some money coming from the private sector. And now, when the EIC has selected the Pathfinder, this investor, they can see the project and they can somehow monitor the one they're interested in. And maybe they can participate in the review meetings and in the final meetings, so they can follow the progress of the project. And in return, the beneficiaries of the Pathfinder, they could have access to the money that this investor has contributed to participate in this program. And they can use this money to start a startup or, or to do other activities. Again, I'm trying to put the focus not only in the public bodies, but also to get more contribution from the private sector.
Thank you very much, Gonzalo. Actually, we have now, I'm working also more and more with private investors. You remember last year we had 2 events with investors, one in France and one in Space Tech Bremen. We will try to do this year again. But also I understand from my colleagues from DG RTD that they are building a trusted investors network. So last week at the EIC Summit, I tried to lobby very actively that this trusted investors network meets our EIC space portfolio companies. As you know, we are in quite big competition with other domains. Unfortunately, I could hardly fight with health and green and all kinds of other quantum. Well, I'm doing quite good job managing to attract more attention, but I have raised it as a question. Also, I want to let you know that I'm working with some investors for the portfolio in space or energy harvesting. Celeste, very short, because we're just finishing and starting the next webinar. Just 2 words.
Yeah, it's more a question. You are developing a portfolio that is very good, and this is somehow funded, as they are for example, the collaborative actions that are funded and the European Commission projects. There is this type of projects, and in my perspective, this would be very useful for the technologies that have low maturity, TRLs, lower TRLs, because investors at this stage, they need the demonstration, the proof of the concept before they start to be interested. So it would be very important to support the ideas, the initiatives from the beginning, even with small exchanges like this one we are having today, to develop the ecosystem, to develop all these system, all these market. You should put the people together in the same room. But of course, startups in the beginning don't have the resources to travel all around. And yeah, this for me, this
Thank
is.
Thank you, Celeste. Sorry, I need to cut you cut you because we have another webinar just in a few minutes. I want to thank to Stefano, Milan, Hira, and Gonzalo, and to the whole audience for our great discussion. I found it very useful and very interesting. I want to thank to Stefania for her amazing patience preparing this webinar and her excellent support on it. Thank you all, and looking forward to see you at the next webinar. Have a good day.
Thank you
all
very
of
much,
you.
Stella.
Thank you.
Just one word. I added in the chat the information on the event that is taking place now at 11 o'clock and the link to direct access the webinar. So if you have interest, please stay with us, and clicking on the link, you join immediately the webinar without registration. Okay, it will be very interesting because we have projects and their experience that is going to be shared. So it will be very interesting. Thank you very much.
Thank you. Have a good day, everyone.
Thank you.
Thank you.
Bye-bye.
Have a good day.